it's a matter of time before regulation begins impacting access to key resources. And this not goes not only for supply chains correlated to carbon emissions, but for those two that are connected to other types of pollution as well. All prioritize a much stricter carbon accounting methods. They're going to start to result in terrific incentives for clean energy. Right. Well, there are risks in supply chains for certain types of batteries that have been a big issue. And so we've used machine learning to search these publications a lot more intelligently and efficiently, so we can just get access to more data sources, and then our benchmarks are more and more accurate and reliable.
Today, we're sitting down with a corporate America's environmental lie detector, Michelle Demers, and her company Boundless Impact do something so radical it's almost shocking. They use actual math to figure out if companies are saving the planet or just saving their face. While most businesses were busy making their logos green and calling it environmentalism, she was building algorithms to measure their real impact. It's like she brought a calculator to a marketing meeting and nobody knew what to do about it. You know that friend who always ruins your workout enthusiasm by reading the actual calories on the menu. Michelle's doing just that, but for $1 billion companies who claim they're going green. She's basically the person who showed up to the corporate sustainability party with a measuring tape and started checking if everyone's environmental promises measured up to their press releases. When companies say they're changing the world, she's the one asking by how many metric tons exactly. Michelle, welcome.
Thank you. Pleasure to be here.
Let's start with the big picture. When you look at companies' environmental impact, how do you actually measure that? Like, what's your process for cutting through the BS and getting to real numbers?
Well, there's this methodology that's been around for probably nearly 5 decades, and it's internationally standardized, and it's called life cycle assessment. It's widely respected in environmental engineering circles, and all that we do at Boundless is take life cycle assessment and got sort of creative with it so that it could be applicable and useful for uh, both companies with products, but also emerging clean tech companies, investors, um, governments, etc. And it is highly reliable because it's very statistically rigorous. It's a methodology that essentially gathers data on the entire environmental performance of a product from its inception, meaning where the materials come from, and all of the emissions and other environmental aspects of producing and manufacturing a product, all the way through the use case, disposal, end of life.
So great that you mentioned it. Talk to me about the supply chains. How do you track environmental impact when you've got parts coming from all around the world?
Right. So sustainability is becoming a critical component to supply chain stability. And as something like 50% of all carbon emissions stem from 8 aggregated supply chains, as we've become a globalized economy, it's really critical that you understand and assess and maintain a certain level of transparency in supply chains. And this isn't just for environmental purposes. This is for economic and financial stability purposes as well. And it's a matter of time before regulation begins impacting access to key resources. And this not goes not only for supply chains correlated to carbon emissions, but for those two that are connected to other types of pollution as well. And life cycle assessment is this comprehensive approach that evaluates every phase of a supply chain, from raw materials extraction to manufacturing, transportation, end of life. And I'm sure you've heard of scope one, two, and three emissions. Scope three emissions are where most of a company's emissions are. I think McKinsey did a study a few years ago and said upwards to 85 to 90% of emissions are in scope three. So those are the ones that seriously sustainable companies account for. And these are also really challenging to track. And that's why clean tech investors prioritize life cycle assessment in order to gain insights in terms of how their investment targets can manage risks associated with emissions, energy demand, natural resource depletion. And supply chains are where a lot of the answers are.
So here's what interests me. You're looking at both traditional energy and the new tech. How do you compare something old school like oil to something like hydrogen?
Well, it's what we do with life cycle assessment is we use environmental key performance indicators, and we do an apples to apples comparison of new energy sources to traditional energy sources. And we look at not only their GHG footprint, but we look at other critical factors, such as their water footprint, or their fossil energy footprint, or their carbon return on investment, or their cost of production. So it's important to integrate both life cycle assessment and techno-economic analysis to have a properly fair picture. And you're going to see genuine competition between traditional energy and renewable and cleaner energy sources in the coming years, because they're getting more and more economically efficient.
So you're spot on. When companies talk about going green, there's always this water usage issue nobody mentions. How do you deal with that, especially with hydrogen production?
Right. Well, I mean, there are some newer technologies that probably use a bit more water, but as they start to evolve, they use less and less. And those efficiencies, there's a lot of clean energy sources like hydrogen, certain hydrogen technologies that have figured out how to reduce the amount of water in their production. And actually, there's a tremendous amount of water used in fossil fuel production that people need to account for, and they often don't.
How do you tell companies to build for tomorrow without wasting resources today?
So, um there's the way that the clean energy revolution is evolving quickly. There are a lot of instances where you're you're economically wise to start investing in clean energy now, because of the geopolitical uncertainties and risks associated with fossil fuel production. And you're seeing really large markets like the California market, the Canadian market, the European Union, all prioritize a much stricter carbon accounting methods. They're going to start to result in terrific incentives for clean energy. There's just places that are like, I think Texas has become one of the largest wind energy and even solar producers in the world at this point.
Can you walk me through how you look at a product from birth to death? What are what are you actually measuring?
Right, so it depends on the energy, on the industry, excuse me. We will pick with life cycle assessment. What we do is we pick a certain number of environmental key performance indicators that are the most relevant for that industry. So, with a battery technology, we'll measure, the levelized cost of electricity, and we'll measure carbon payback time, and we'll measure volatile organic compounds that are used in the manufacturing process as well as water. And with uh, uh, a like I don't know, a green chemical, we might look at a number of air pollution metrics or toxicity metrics. It depends on the industry, and what we do is we put an RFI together and collect data from the company on their production process, on where their materials are sourced. We have a whole set of questions we ask that are related to the EKPIs, and we do our life cycle assessments in a matter of weeks versus months at Boundless. Because we have figured out ways to do the life cycle assessment more efficiently. And we also think it's really critical to do that apples to apples comparison. So you're comparing one product to both traditional products in its vertical, as well as contemporary newer products in its vertical. And so we have a fairly elaborate process for both collecting data, analyzing data, having industry experts do a formal independent peer review of that data, and then do a report that showcases and translates the life cycle assessment. Because you also want to be able to make sure a company can show the life cycle assessment to investors, to customers, to strategic partners, and they can understand the meaning of it relatively quickly. So, using infographics and charts that are easy to understand and that sort of showcase how a product is different and performs better is really critical. So we do all those things.
So, what help me to understand what does your service unlock for these companies?
So it sometimes unlocks places where they are underperforming or outperforming the competition. And obviously, if they're outperforming the competition, they want to sort of tweak those aspects of their production and make them even more efficient or more competitive. In places, we can identify hotspots where they might be flying materials from really far away, and we might be able to suggest that they pick alternative partners in their supply chain in order to reduce the GHG footprint, or they might use renewable energy in certain aspects of their manufacturing, where they didn't realize what big of a difference it could make. We did that with a biopesticide technology that had terrific numbers when it came to improving the environmental performance and reducing the ecosystem and toxicity impacts of the product. But then we realized they were flying materials for the product from all over the world.
So, many times you mentioned materials. Let's talk about the rare earth minerals. Everyone wants clean tech, but nobody talks about what we are digging up to make it happen. How do you balance that?
Right. Well, there are risks in supply chains for certain types of batteries that have been a big issue, and rare earth minerals are in a lot of batteries that are used for electric vehicles, for transportation, other transportation fuels, as well, like sustainable jet fuels and marine fuels, as well as industrial fuels, as well as other forms of energy production. So it is really important to understand the supply chain and to be smart about it, as well as to understand how we can recycle those materials. And there are increasing number of technologies that are figuring out how to kind of deconstruct a product after at the end of its life cycle, and reuse a lot of those precious metals. And there's also creative mining techniques that you see. They're not even mining; they're production techniques. I should correct myself. Like you see with the salt swamps in the south western United States generating lithium.
I think this question just popped up, but how much do you use AI in this, or do you
We do.
actually?
We do. We're using machine learning in the way that we do. So we search a lot of scientific literature when we're looking for benchmarks. So if we're comparing a green hydrogen project against traditional projects, we have to go into the scientific literature, the industry literature, and look at the existing LCAs and data that is out there as we build our industry benchmarks for comparison purposes. And so we've used machine learning to search these publications a lot more intelligently and efficiently, so we can just get access to more data sources, and then our benchmarks are more and more accurate and reliable.
That sounds great, really. How do you help companies in developing countries go green, but without killing their growth?
So I actually uh, I actually think going green is economically wise in the long run. I would argue there are deep economic risks and geopolitical uncertainties in partnering with a lot of the oil producing countries that are run by non democratic authoritarian regimes like Saudi Arabia, Russia, Venezuela, Iran. And it's kind of a disturbing trend. And I think clean energy, on the other hand, is for the most part save those supply chain issues around the rare materials we were just chatting about. They aren't tied to these dangerous geopolitical trends. There are a lot of economic incentives in keeping your economy from being one of the major emitters. And I think um, as I mentioned, the EU, Canada, and the California markets are all really increasing the price of carbon and making and creating a lot of incentives around in terms of adhering to clean energy production and use. Um, and all three of those robust economic zones are going to keep catapulting toward clean energy, which arguably is going to be more and more efficient over time. You've seen it catching up with traditional fossil fuel energy. And I think it's in a number of instances, you're going to see that the choice is clean energy because it's a better economic bet.
Yeah. So I'm not sure if the next one is tricky, but when you look at hydrogen projects, how do you separate real solutions from greenwashing? Is that possible?
Absolutely. And as you said earlier, we consider life cycle assessment to be the anti greenwashing tool. It's the kind of greenwashing antidote. If you perform a verified third party LCA, there's a lot of folks that are trying to do their own internal LCAs, and they don't always understand it's really important that you have to pay attention to international protocols for life cycle assessment. But you want to identify the impact per kilogram of hydrogen produced. And when thinking about it from the production specifics, you need to consider feedstocks and energy source. If natural gas is used as the feedstock, hydrogen production is likely emissive unless carbon capture is utilized, like with blue hydrogen. But if green hydrogen is claimed, you need to specifically analyze electrolysis of water. You need to pay attention to the electricity source used. Renewable energy is required for electrolysis of water to claim its green hydrogen. So, other hydrogen production methods exist, such as biogas from food waste to biomethane, but they all need analysis. And then you can do a comparison and determine which type of fuel is the greenest in which case.
You know what? I would like to hear and see such analysis, like in terms of at least continental regions, because that's kind of a topic of a huge debate. But everyone's talking about actually one other thing, and that's circular economy. How do you actually measure if something is truly circular?
Right. Well, a lot of it is measuring that end of life, because when you put these batteries into the ground, they can be very toxic, and people are concerned about nuclear waste now that nuclear is having a resurgence. We analyzed a company that's taking nuclear waste and turning it into a fuel. There are it's a tricky chemical process, but it can be done, and it's interesting because you are seeing it's taking that product and using and reusing certain aspects of the materials in the product. So it's the circular economy is a great term, and it's become very in vogue and popular. I think we're moving past the age of recycling because we have to, and we have to start looking at where the materials are that we're sourcing. So the beginning of life is also really critical, and what types of materials. And you're seeing more and more cellulosic tree-based materials being used in bioplastics that you're using in terms of straws and silverware and all sorts of consumer packaging goods. And so it's the materials space as much as the fuel space is undergoing a massive re-engineering and revolution. But it is important at that beginning of life and end of life to completely rethink things. And I think that's happening. I don't, I would argue it's not even happening fast enough, but it is happening.
Interesting. Uh, you mentioned several times batteries and hydrogen and so on. Let's talk about energy storage. Actually, batteries, hydrogen, other kinds of storage. How do you figure out what's actually better for the planet?
So, great question. And the main metrics that we measure when we're looking, we've analyzed lots and lots of battery technologies. There's and there's obviously also lots of energy storage options. In addition to batteries, there's hydrogen, there's mechanical, um, and the main ones we look at are carbon intensity per kilowatt hour of energy storage capacity, cost, because it doesn't matter how great your technology is if it can't compete in the marketplace, it's not going to scale commercially. Energy density, as well as capacity for energy storage. So we look at those, and as you can see, life cycle assessment is just very um, doing techno-economic analysis alongside life cycle assessment is just very wise, and smart investors do that. um, so I can explain some of those metrics. Would that be helpful
Yeah.
in more detail? Okay, so carbon intensity would be the life cycle GHG footprint of the battery normalized to 1 kilowatt hour of energy storage, and cost would be just the production cost of the battery itself, also normalized to kilowatt hour storage. So it's always really important in doing our analysis that we're trying to create that apples to apples comparison and using the same unit of measure so we can do proper comparative analytics. And on the cost side, there's also levelized cost of storage, which quantifies the discounted cost per unit of discharged electricity for a specific storage technology and application. And it divides the total cost of an electricity storage technology across its lifetime by its cumulative delivered electricity. Um, and energy density is the amount of energy a battery can store relative to its weight. And energy density is typically measured in watts per hour, watt hours per kilogram, excuse me.
So, when you're advising companies, how do you help them balance quick wins versus long term changes?
So, short term wins are achieved through informed decision making that results in optimized processes like supply chains that consider long term changes, or at least track to knowing when they need to pivot to a different process when changes occur. So it's not versus. It's more. I think a lot of people get hung up on. You feel like you have to have a choice when you can actually balance short and long term at the same time, which is where we see the power of life cycle assessment thinking. um, by looking at the long and the short at the same time, when those environmental changes do happen, you're going to get to that short term period thinking faster. And anyway, I hope that's helpful. But there's it's very important to understanding what wins you have over time.
Yeah. Yeah. How do you measure the impact of these massive renewable energy projects on local ecosystems?
So it's not always easy, but it is when we look at specific projects, we're looking at obviously health and human health impacts. We're looking at ecosystem health impacts. We can look at in one of the metrics that's very popular with life cycle assessment is marine or freshwater eutrophication. And what that's measuring is toxicity in water, um, how much the water is polluted, essentially. We also look at air pollution, and we can look at ozone depletion. We can look at parts per parts per million of particles. We have a number of different metrics that essentially assess how local communities are affected.
What actually matters more? Immediate carbon reduction or systemic change?
So that's a tough one. I ideally both, if we're being hopeful. But I'd say systemic change is more important because quick carbon cuts often can just go away and then not actually have any real impact. Because carbon emissions can accelerate without systemic change. Um, and I'm assuming this question might be coming from the argument that fossil fuels are needed to transition the system to less fossil fuels. And this is true if we're to limit energy price spikes. But according to the International Energy Association, we don't need any new fossil fuel projects. We read a project, or excuse me, a paper that they said that they sent that they recently published, and it talked about the. I'll just quote here: "No new long lead time upstream oil and gas projects are needed." um, in the NZE scenario. Neither are new coal mines, mine extensions, or new unabated coal plants. So, I mean, there's going to be continued investment in existing oil and gas assets, but we think that sequencing the decline of fossil fuel supply investment and the increase in clean energy investment is vital if those sorts of damaging price spikes or supply gluts are going to be avoided.
When companies come to you with their sustainability plans, how do you know if they're actually serious?
So it's important to be, sort of put your skeptical hat on and actually ask them for specific data and then ask them where they source that data. And that's part of the LCA process. We have data integrity scoring tools at Boundless that can look at both LCA data and TEA data and analyze if there's been kind of overestimations made or wrong assumptions made, if the data is not reliable, or if the data was sourced against a paper that was written, in excess of 5 years ago, because a lot of these markets are dynamic and they're changing quickly. And or someone could be comparing themselves to using a data source from a technology that's not closely related enough to their technology. It's just kind of a cousin. And we see mistakes like that happening all the time with folks that are just not putting the right assumptions into their calculations. So with greenwashing, you got to be really cautious of people overestimating the carbon removal potential. And we see in certain technologies, it is happening, and you can't ignore risks and uncertainties. You have to acknowledge what are the potential risks and uncertainties associated with the deployment of a technology. Um, and then it's really, I would say be hesitant when you say large claims of one technology on their ability. Um, are their abilities where they don't clearly state the assumptions and original sources of their data.
So it's literally much better to consult with you than to do the guesswork.
Absolutely. It's a tremendous time saver. We get that feedback all the time from companies.
And what's your take on carbon offsets? How do you tell if they are actually doing what they claim?
Right, because they claim a lot of things and
Yeah.
it's not easy. I would say they work when they result in additionality. So you don't want to give people carbon offsets for something that's already being achieved, whether it's a technology or land conserved. It needs to be new and continuously monitored for those carbon offsets and making sure they are actually being achieved. For example, seagrass that's being used. What is the extent that the seagrass has been maintained and fostered so that the carbon offsets are actually occurring? There's a lot of folks, making claims on nature-based assets, but they're not actually properly monitoring them, and so the carbon offsets need to happen when those nature-based assets are actually being watched and observed and monitored.
So I would like you to kind of shortly tell me like the case study of a certain company where you've done your research and advising, and at the end, how the result looked like.
Um, okay, so right now I'll just throw this out there. We're doing
Yeah.
carbon direct removal. We are working with the X Prize Foundation to assess the 20 finalists. We're doing both life cycle assessment and techno-economic analysis on the 20 finalists for the carbon removal prize, which is backed by the Musk Foundation, and it's the largest X Prize in history. It's like $100 million purse. So the
Well,
first place winner is going to get $50 million. So that's a really big amount of money, transformative amount of money for a company. So we are
right.
assessing the 20 finalists across 4 different tracks. So carbon direct removal for air capture, land sequestration, um, rock sequestration, and ocean sequestration. And so we're analyzing 4 uh, different categories of really cool technologies. And so that is a project I love talking about just because we're collecting data from the companies, life cycle assessment data on their environmental performance, but also their cost. Are they going to be able to truly economically scale? And what are the numbers they're stating to get to that commercial level of competitiveness and to unseat, other technologies that they're up against? Because these carbon direct removal projects and industries are becoming really competitive. So it's been a lot of fun, but we're collecting data and looking at both their obviously, their ability to abate GHG emissions over time. We're looking at their durability and how well they're going to be able to maintain a kind of steady growth to commercial viability. We're looking at their um, carbon, in addition to like just their ability to abate carbon, their their ability to reduce the cost of carbon, so that they can actually unseat others technologies in their same vertical, and change the status quo of doing things. And all of this requires a lot of data collection. It requires us pointing out where we think a lot of the assumptions need to be looked at more closely with some of the companies, where we think the assumptions are too, like I was talking about earlier, overly optimistic, or they could be assuming renewable energy production in the state of Texas, where their plant is, of 80% by 2028. And we look at assumptions like that and we think that's probably not likely to be the case. That's only 3 years away, and 80% is probably a little overly optimistic. So we question assumptions like that.
Yeah.
And
So the
but the
bottom
report
line.
is also really important too, and how you translate all of this. Sorry.
So the bottom line, when you look at all this data, are we actually making progress or are we just moving problems around?
Yeah, I think we're making progress. I think it's slow because these are complex technologies and there's a lot of economic, pushback. Um, People find change difficult, and moving to some of these new technologies is harder in certain economies than others. But I see a tremendous amount of progress being made. If you look at the amount of GDP and jobs and tax revenue, as well as regular revenue, that's been generated by the Infrastructure Inflation Reduction Act, and many of those being made in red states, I think it's going to be really difficult for them to claw back all of that legislation, because there's going to be too many folks that have benefited from it. And I think
Yeah.
you're seeing that in a lot of these industries. You're seeing a tremendous amount of innovation and new companies, new industries, new jobs. And so I don't see that changing anytime soon. I think there is going to be, a certain amount of fossil fuel production that is part of the transition process. But I see this kind of, the horse has left the barn, if you will.
Oh
Um,
my God. You just started the huge topic for which we need another 2 hours. But yeah, for sure. I'm listening to you and nodding like definitely. But for the end, can you tell like the companies that are potentially interested in such services, what are the benefits?
so you're going to understand, if sort of the contours and details of your sustainability story at a much more kind of surgical level. It's just going to make you smarter. If you're a clean tech company, and even if you're a company that's claiming sustainability on your product, you're going to be able to understand how to manufacture your product more efficiently. We'll identify hotspots for you, so you can actually make improvements in your operation that are really just smart improvements. So um, we see life cycle assessment and techno-economic analysis as critical parts of smart companies. But we also see it for clean tech companies that have an outsized, for which sustainability is an outsized aspect of their value proposition. We see this as the big differentiator. We're going to help them get to market faster. We're going to help them commercialize and scale faster. We have companies, I think over 75% of our customers have said to us that they've raised money more quickly and more easily using our reports, because they're very helpful at translating the LCA into, business terms, if you will.
Yeah. So we'll make sure that we publish some of these, hopefully, and show the market what actually is happening through them. Michelle, thank you so much for being my guest today.
Thanks for having me. It's been a pleasure.
Looking to amplify your brand in the hydrogen energy sector? Welcome to H2 Energy News, your go-to platform for impactful industry insights. Every month, we connect with over 80,000 visitors and generate more than 251,000 page views. Our reach is unmatched, with over 1.2 million web impressions and a loyal social media following of 9,000 plus. Our newsletter reaches 77,000 plus subscribers, decision makers, industry leaders, and innovators. Want to target specific markets? Our geo-targeting capabilities cover Europe, the United States, and the MENA region. We reach key stakeholders, 27% senior executives, 32% directors, and 20% owners and partners. H2. Energy News isn't just a news platform, it's where the hydrogen energy community converges to shape the future. Join us and let's make an impact together. Visit energynews.biz and take your brand to the next